as always, thank you all so much for coming. Hope you're looking forward to a lively conversation with our two panelists and experts in this area. Designing or renovating labs, how do you avoid problems? There's never a problem with designing or renovating or building a lab, right, guys?
Never.
Well, I will start with the intros, and I want the guys to intro themselves, even though I know them both. Full disclosure, I have worked with both of these gentlemen, whom I call friends in the dearest way, and wonderful to work with, and just the most wonderful of guys. And I'm looking forward to a really great, fun conversation. So everyone that has shown up, thank you very much. Please engage in fun, banter, if you wish, in the chat. But then for questions that you want to make sure they get answered, please, please, please put them in the Q&A so that we can see them, because that's where we, mostly me, will be looking for them. The chat has a way, as people add in, your question just scrolls away and we don't tend to see it. So in your own interest, I would offer that suggestion for you. I'm Jonathan Klain. I am our host and moderator here at BioRaft. And again, thank you from the entire team here at BioRaft. But let's have the guys do their intros. And Cary, since you joined first, we'll give Dave a couple of minutes still here to catch his breath or whatever from running over from the class. It's probably virtual. But Cary, go ahead and tell them who you are and what you do, please.
Well, I'm going to be kind of brief, not much different than what you posted. My job is working in the engineering dean's office for Arizona State University, and I'm sort of the first contact for all research professionals that as soon as we hire them, I contact them and do all the programming for their future research laboratory. In addition to that, I help to create different kinds of processes here to try to make everything run a little bit smoother, assist them as they get new grants, new research that they may need new equipment or power, some type of infrastructure. I like to say I'm not the policy guy, I'm the get it done guy. That keeps me as an advocate and ombudsman for the researcher. And I'm not a roadblock is what I try to tell them. And I'm here to try to do the best I can to get their research grants and deliverables as quickly as possible. I think that's a good start.
I think it is. I think it's an excellent start. And it looks like our participants has actually shot up a bit. So that's wonderful. We're at 160 and nice. And Dave, why don't you also now do your intro, of course. Please.
Hi, I'm David Griffiths. I'm also with the College of Engineering at UC Davis. And I put together new labs, new buildings, different structures to support research and to support learning. Work with new professors as well. Make sure that research can happen. I always say I don't get to do the research, but I get to have a part in it by making spaces for it facilitated. So that makes me feel good about what I do.
You should. Oh my God, these labs would never get built were it not for you guys. That's for sure. And I worked with both of them for years. We all had a blast, lots of challenges, maybe frustrations, but let's get into it and let's talk about how this can work and what are some of those challenges. We can call them problems, but let's just call them challenges, I think. We all know there's a lot at stake. Engineering labs. So I reached out to Dave and to Cary, not just because I knew them and it would be fun, but because in engineering, as I think a lot of you know, but I think for the three of us, I can speak, engineers build all sorts of things. Arizona State, the Ira A. Fulton Schools of Engineering, when I left, had six schools. You're up to, I still am a student.
7 now. Yeah.
7, that's what I thought. 7 schools of engineering. And Dave, remind me, UC Davis, 8 very large departments.
Yeah. 8.
Right. And both with a lot of other facilities further out, off campus, et cetera, all sorts of challenges. So, everything from bio to chem to rad, to mechanical, to civil, to aero, you name it. Engineers like to build it, take it apart, destroy it, or blow it up. All right, so let's, we already did what's the best advice, and so that is what we had posted there. But maybe let's jump right into talking about how we go about this, right? How do you guys go about this? Because I know, because I've seen you both in action. So, and I'll just alternate starting between you, and I'll start with Dave actually first, since Cary did the first intro. So let's start with before it gets going. So what sort of pre-programming stuff do you do there, Dave, that you find really helpful? Any things you consider and information that you try to get before the project even gets going?
Yeah, I try to extract as much information as possible at our initial meeting, which is sometimes before the professors get here. If I can talk to grad students that work with them, sometimes they'll come ahead, and I can get information on what equipment they're doing, right away, what research they're doing, what it entails, what they need, how big of a space they need. Are there gases? Are there chemicals? All that comes into play with where I can put them, and where I can make sure that they're successful in what they do.
Yeah, great. And Laura, I love the conversation as it goes. Laura put in the Q&A, but it's really just a comment, which is very nice. If possible, meet with the actual tenant and researcher. Yeah, absolutely. Good. Cool. All right. Well, we're off and running. Cary, what about you? What else, what other things in addition or the same that you would like to talk about that you do there at ASU?
Sure. Well, I think Dave and I are on the same page that way. Obviously, we're what I call, I do a lot of what I would call front end planning. And the first portion of that is information gathering and getting figuring what the program is. I'm a geek, so of course I look them up. I read their research papers. I kind of want to be able to speak their language when I first meet them. It's a people business, and a lot of these folks are moving here. They don't know anybody. We're the first people they're going to talk to at the university, and they could be coming from anywhere in the world. And so I try to get to know a little bit about who they are and help them feel comfortable that we're going to work with them and welcome them to the university, and we're excited to have them. And then I try to find out generally, have they ever been part of building a lab? What kind of labs have they been in? And some of these folks have just finished their PhD and they've never done any kind of lab work. Other folks are, tenured professors that are coming over with grants and research and have to get going right away. I try to find out what kind of promises were made. I do early expectation management. Some folks that we hire, I'll call them folks, but they come over and they've been promised the moon, and I realize quickly that that's an expectation that I'm not going to be able to make without a whole lot of upper management help. And other folks, they know that it may take us 6 months or a year to get the lab, and we need to find a temporary facility. So I'm information gathering, just like David is. I have a lot of forms that I use to make sure I don't miss anything. But the initial contact for me is about building a rapport. And getting a comfort zone that that we have a good line of communication, that they feel free to call me, write me, whatever questions they want to have. I try to have a transparent process so that we have if you will, we're teaming up for their research lab.
Yeah, cool. And would this be a good time for me to share that engineering lab design and use checklist that you sent me? Because I can do that in the chat.
Yeah, that's fine. Absolutely. This is just, I worked on quite a bit of front end planning. I think Dave's the same way. We both kind of like that, going through certain phase gates and doing programming, getting everything we can. The more information we get ahead of time and pass off, the less we have to go backwards with a scope change, or maybe we don't have the right building. So.
You used a phrase that I like a lot, expectation management. And I saw Dave smile during that. I think all of us have experienced that, where the PI maybe in a private conversation says, this wasn't what they mentioned when I was coming on board, right? So maybe both of you guys can talk about your strategies for that a little bit. How do you manage the expectations? What if the project goes in a different direction than people initially thought? Because I know that happens a lot. And how do you help them maybe really have the perspective of success when we're so loss averse and they feel like they aren't getting what they originally thought? And so I think I started with Dave last time. So Cary, I'm going to ask you to start in on this one, and then Dave to join in.
Dave's got 3 hours of warming up. Well, oh man. So for me, this is all about teamwork. The construction realities are what they are. With COVID, we've had a lot of issues here with material delivery, getting subcontractors to bid work. Budgets are outrageous. In this particular area in Phoenix, we have a $12 billion manufacturing technology plant going up, another $8 billion plant. Many of our pipe fitting people that are doing toxic and flammable gases they're contracted for the next 3 or 4 years. So there's those kind of challenges. And I think in my experience, researchers and generally faculty, anybody in a university setting, I can't speak for most of my life was in entrepreneurship, not in a university setting. But they're looking for information, for predictability, that they can focus on their research, their deliverables when their equipment's coming. And they don't want any surprises. And they don't want me to tell them something a week before when they've been planning something for months. So as early as possible, I try to let them know the reality as we know it. Okay, it can get shorter, but it usually only goes one direction, and that's longer. And then again, I am not in a position where I want to tell somebody they shouldn't come here. I would never do that. So I immediately gather information, then I take it back to the department, and I let the folks that made the promises sort of, talk it over about what they meant, or a little redundancy between the parties, because I don't want to be, like I said, a roadblock to anything, to our research goals or to what's happening in the university.
Yeah.
So these, I try not to play much in the way of politics. I'm really interested in getting it done.
It's funny as you're talking. No, it did. Yeah, excellent. As you're talking, I'm thinking in terms of the people I know that we would, delegate it upwardly to. And then, so Dave, what about from your perspective? And I can think of who you would use to upwardly delegate if you needed to, but talk about whatever you'd like.
Well, similar problems, and everybody knows about the issues they're having with getting container ships into California. That was causing huge problems on large projects. It put back. I had to get a pipe that took 3 months to put in. That I thought at first they were kidding. So I researched it, and I researched all over, and I could not get this pipe. This sewer pipe came in 3 months later. It backed up my project. We had to be really flexible about doing other things because we wanted to get this project on the road. We've had to be really flexible. I had a professor move into a lab that was 75% complete because the 25% remaining, his laser curtain and microscope, they weren't going to be there. So we did build a lab that was 75% complete so that he could go, and he was able to do that. We've had COVID labs for testing COVID wastewater that had to be put together in 3 weeks because UC Davis and the city of Davis got money from the governor that said that's what we were going to do, and that's what we did. And timing was something we had to put together. We try to do everything we can within the office. But if there's extra push, like with the COVID lab, then it went a little higher because I needed resources that were going to be available to make a lab happen in 3 weeks. And that's what we ended up doing.
Yeah. You know, it's interesting that you mentioned this, Dave, about the supply chain woes, to put it mildly. My brother is semi-retired from working for Timberland, actually, and used to deal with a lot of this. He'd figure out ways of getting rid of factory defects and the like. He could get rid of anything he wanted to. So he still dabbles in that these days. And I was talking to him, and he was talking about container ships and stuff in storage that they can't get out of storage, and they can't move this and they can't move that, and this customer is upset and that supplier is upset, and everyone's paid for stuff, everything's bought and paid for, but they can't move it, right? So totally get it. That's just adding to the challenges here. So the next, I think, continuing in this direction about talking about expectations, because we all have expectations, and I think from my perspective, but I really want you guys to say, you know, PIs have a certain vision of what they think their lab will look like, but I think they, and by I think, I'm going to say I know, they often want as much flexibility because they're not sure where their research is going to go. So they kind of want to be able to do almost anything. So how do you deal with the budget when it comes to that, and scope creep, the scope itself, any considerations, maybe their grant limits it, or the department or school does some sort of constraint on it, and the space itself may not have come. So go in, you know, whatever direction. And it's easy for me. Dave, you were the last to speak, so now you're the first to speak, and I just keep going back and forth that way.
All right, yeah, the constraints with the lab expectations can be difficult. I always start with what is needed for the research, because there's oftentimes there's things that are wanted and things that are needed. I try to provide both. I try to provide as much as I can for the incoming researcher. Sometimes those things within the startup budget aren't going to happen. I try to put as much in as we can. But you know, the necessity is the research has to happen one way or the other. Have to put together a lab that is going to work for the researcher. And if we have to be flexible in space with other researchers, if we have to, be flexible with equipment or in methodology, how we set up the lab, then that's what we do to make sure that they can do their research.
Cool. Great. Cary, what about yourself? What do you want to add to this conversation, managing expectations still, and these constraints?
Well, for us, there's many pieces to this puzzle. For us, you know, what we're interested in doing is extrapolating ahead maybe 6 months for their currently funded research, and knowing that as they get new grant money, as they start to become more successful in the program, we'll be putting more money towards them, and they'll have more funding. It's on our campus. I don't know what it is at UC Davis. We're dealing with buildings from 1923, to this year, and so one of the issues is some single-story buildings, I can throw an exhaust fan up fast, no problem. Other buildings are maxed out on their mechanical systems, and I can't put them in there, even though that may be where they want to be, because the other researchers are in that area. So it's not always convenient for them in terms of their location. We're also working with budgets, which are just outrageous right now. And so typically in our engineering school, we do a scope of work. We know about what square footage, I've done 150 labs here. I can tell you what they need in their lab. I can tell you about what square footage they need. There may be a little of this or a little of that, but we generally know. But being in a building and picking up an area near where they want to work, that's a whole nother difficult issue. So I always say time, money, permission, I can get it done. I need those three things. And so this combination of, early on, I tried to work with my team to identify the space that we're going to put the people. Once I know that, it's a lot easier because I understand the building infrastructure and the mechanical system of capabilities, and we pretty much know whether there's enough power, those kinds of things. If we have somebody come over that has an instant deliverable and we're backlogged on getting materials or labor. Then we look for what I would call hoteling or sharing, labs. And then we're fighting a culture that's been silo oriented, where everybody has their own lab, their own space, their student has their own desk. And as we've expanded and grown tremendously here on this campus, we're having to sort of change that culture and have people share facilities more. And I think that's the future. I mean, we used to have so much land and building, and that was never the case. But now we really have to start to get better at that. And I have one quick story. I had somebody come over from a back east school, and I put him into a lab with, it was only about 500 square feet or so. And I said, you're going to have to share this fume hood. And I said, I'm really sorry. I was very apologetic. And this person looked at me, and it was a 1957 building on our campus, which is one of our older buildings. And he kind of looked at me and he goes, I just came from a building that was built in the 1800s, and there were 27 people sharing it. And so I realized that our standard here was still way better than where this person was coming from. And so there again, since we don't know what standard we're being held to at any particular time, we're sometimes we're heroes and other times not so much, depending on what their expectation is, like we were talking about.
Perspective, right? If their bar is very low, it's easy for them to feel good. But if their bar is very high, anything below that, we feel bad, even though it might be the same endpoint, right? So totally get it. I got a couple of specific questions I want to ask the guys. So left off with Cary. What's a technique that you use, or more than one if you'd like, to solve problems? Because a lot of what I know both of you guys did, and a lot of what I did, was solving problems. Very much, I think we're all a bit of troubleshooters and problem solvers. I will admit for myself, sometimes I'm the problem starter or the trouble starter, but what sort of techniques do you use, Dave, Cary rather, and then Dave?
Well, so I'm going to give you something maybe a lot of people haven't heard of before. I spent 17 years in patent law. And one of the things that we do there is when we get a new invention or a new idea, we have to decide how is it different from other things. And what we do is to look at the functions of something rather than the structure. And this is a great technique, and it's really helped me a lot in problem solving when we can't figure out how to do something and we're thinking about, what's in the Home Depot aisle. I'm just using that as an example. It's because we're thinking structure. And so we try to break things down into a function. And one way I can describe that is maybe a pen. I don't know if I'll be able to get this on the camera.
Yep.
Oh, just one of them, this one. So you have a writing instrument, and if you were to break that into functions, you might have an ink supply function. You might have a gripping function, a retracting function, a holding function. And you can tell if you ever walk into an aisle at Staples and there's 5,000 different kinds of pens, that when people were looking at how could we make this pen function, even though it's just a writing instrument, they found many, many different ways to retract, many different ways to grip, and so I find that if you think about something functionally when you have a problem, and it could be a mechanical problem, it could have to do with how you're going to get water somewhere, or it could be just about anything. And you look at what's the function that we have to have. And then you start looking at the structure, and your mind starts to open up because the language and how you program your mind and how you see things is different when you see it structurally in your mind or when you think about how it's got to work. And I find this very useful in many of our engineering facilities and research, where we're sort of inventing as we go along with what we have.
Yep, I think, and speaking for the EHS folk, I think we can easily get to where we're thinking very concretely about the structure of what it is we're trying to do. Dave, what about you for problem solving when things look like they may be going awry? Not that ever happens, of course.
Yeah. Well, I'm pretty level-headed about most projects. I've done it a long time, and I lean on the people around me, my team, a lot. As you know, John, when you were in safety working with us, I brought you to many job sites. When I had an issue to work it out. I bring in fire, I bring in EH&S, I bring in our design and construction management team. I don't think I have to wrestle with everything on my own, and I may not have the best idea, but I want the best idea, and that's what I look for. So I'd have to just say, communication, and that's I never have a problem saying I don't know, but I would have a problem saying I don't know and I can't get the answer. I have a lot of people that I can get the answer from. I can call Cary, I can call you, just to make sure. And the whole thing is to do the due diligence required to get the right answer to the challenge. There's always the quick answer, and I've seen many people fail on the quick answer. When Cary was talking about exhaust on floors and fume hoods, I had a researcher who wanted a 6-foot fume hood, had to have a 6-foot fume hood. The space would not support it. We went to a 5-foot fume hood and balanced out a floor, and that's how we got a fume hood. That was supported by the HVAC team at facilities. After an engineer had told us that we couldn't do it, that it wasn't going to be possible, but we researched it further, and they were just the comment that it wasn't possible was with the 6-footer, which he was correct, it wouldn't work. So we went to a 5, and we got our fume hood in, and everybody was happy. So yeah, I just communicate with everybody to solve it.
Yeah, I'll chime in just very briefly here. So for those that aren't maybe as familiar, so I was the embedded safety professional, safety director, basically, different titles at both ASU and UC Davis in the colleges of engineering. So my office was, like across the hall from Cary's, and he would come into mine and sit down and we'd chat. I'd go into his and sit down and we'd chat. Dave's and mine were next to each other at UC Davis. One of us would go into the hall and just stand there and talk with the other, and vice versa. It was just a constant. But so there'd be some things that, we could decide, but then like the guys are saying, they have to go to facilities. They have to go to the people doing the design sort of stuff, right? For the university at large. I would then go, with Dave or Cary or on my own and get fire safety, get chemical hygiene officer, get, whomever we needed. And sometimes those meetings in the lab, when we had all the people there and we could just have a conversation back and forth, very open, very transparent, and the PI could see in real time, we were trying to do things for them. That sometimes, I would say, guys, is when the magic would happen. Cool.
And often solutions would come out from those conversations that all of us on our own, when we were discussing it separately, didn't come up with. But everybody being in the same room, all of a sudden we had a solution.
Yeah, it always went better, I feel. So let's talk about that, the people that you're getting input from on this. So this time, Dave first. So Dave, whose input, and then Cary, whose input do you request on these projects that you find to be the most valuable, perhaps?
Everybody. I start off with the professor. Like I said, I talk to grad students. I talk to equipment manufacturers. I talk to EH&S. I talk to the fire inspector. I talk to design and construction management and our facilities management team. The main thing is communication on the front end, like Cary was talking about. You have to have the communication on the front end. I check everything off before we start, so there's no surprises, no ADA issues. We have to be concerned with ADA. We have to be concerned with EH&S. We have to be concerned with the HVAC exchange rates. If you're doing, a lab that is dealing with feces, what are you going to do with that smell? You know, you're going to put in a snorkel, you're going to crank up the exchange rates. There's a lot of things that you can do. And having all these people involved at the front end of the project helps.
Yeah, and for those unaware, UC Davis is an Aggie. So we do have copious amounts of mostly animal feces, but
That was a real, yeah. That was a real example, yeah.
Sometimes building septic systems don't work, and I know that for a fact at both universities.
Yeah,
Cary, what about you?
We try to do a wind pattern study before we start putting that stuff up there. That's not blow it toward the neighborhood.
Yeah, no, definite. So Cary, what would you like to add to Dave's answer on?
Well, that's a great answer that Dave had. I mean, I'm the same way, you know. I would say my greatest resource at the university, there's really two. Lab managers that have been there forever. You know, we're very blessed with some people that are 20. I try to get to them before they retire. They've got 20, 25 years of, they've seen just about everything. And so I think our lab managers are probably my strongest, you know, go-to folks, even when it comes to certain kinds of equipment, you know, maybe there's, or shared equipment. They know their area, they know all the equipment, they've seen lots of problems. They're great instructors and mentors for the incoming researchers. So I go to them first. And secondarily, our building infrastructure problems, and I work very closely with facilities. I'm in the middle of a project, and it's very easy for me to fund, say, fixing a leaky valve or a steam valve that's not working or something that needs to be abated. They just don't have the money to do it. I don't know about UC Davis, but I don't know the exact number. I think we're $500 million behind in infrastructure. You know, repair, and I heard USC is $1 billion. And these come from trade shows that we've been to where people say these things. And so every project I'm on, I get a hold of someone at facilities and I said, I'm doing a project here. Is there something I can help you with? And then, you know, they help us too. You know, if I have a doghouse unit on the roof, or I'm having issues where, you know, we're getting dirty filters regularly and they're not being changed out enough, they help with, you know, we work together. And
Nice.
so those two avenues of, I'll call them assistance and alternative planning, they're very helpful.
Yeah, yeah. And only because I've worked at both places, let me help the audience with language. So lab managers at Arizona State are, or at least in engineering, are basically the equivalent. They work for the school, or at UC Davis, it would be like a department safety coordinator. Whereas at UC Davis, a lab manager is usually, there's one per lab, and they're a researcher or a postdoc or someone like that. So just to help everyone here understand who we're talking about. Cary's, and I know exactly who he means, right?
Yeah, you know, and I don't think about the nomenclature, so thank you for that.
No sweat. No. Yeah. A rose by any other name would smell so sweet, as someone said. Pretty sure it was Bill Shakespeare. All right, let's keep going. We've got a few more minutes here for our conversation. We'll do our poll as usual in about probably 5 to 10 minutes, and then we'll get to your questions. And I've been looking at the questions and really looking forward to that part of this. But so we'll start with Cary here on this one. So we're still sort of going through a little bit of front end, but it's also midstream. Phase gates or check gates, sort of trying to limit scope creep, or you know, maybe changing one of those. What are some of the things that you do regarding that?
You want all my dirty secrets, huh?
Yeah.
Well, it's very important to me. I don't know, very important. That's my value system. To keep our projects on track and on schedule. And I know it's important to the researchers. So what I explained very early on, we use graphs and all sorts of things that my boss creates on Excel. He's a master. And we try to show that when we move, what I'll call a phase gate is from, you get all the information, it goes to an architect and an engineering team, they're doing the design, then it goes to permitting, and then it goes to a contractor of some type, depending on a budget. We have different construction groups that we use. And I tell them, look, if you make a change and it's significant enough that we have to change the drawings and the specifications that are going to be bid, we have to go backward, and that could extend the project months. They think it's one change, but for us, it could be weeks or months before the work is able to be completed and then move to the next phase. And so I work really hard at not necessarily getting a sign off, but explaining the process. And sometimes there's nothing we can do about it. All of a sudden, that guy gets a $5 million grant from one of the agencies, and he says, oh my gosh, you know, I need this now. And we have to make a decision. Well, is that going to be another project? Are we going to phase the project? Is there a part of the project we can complete and get him working before the next phase? What's his deliverable date? So all of these things get sort of tied in. But I think for me anyway, the important part is not only am I elevating up, but I'm elevating, I guess up and down isn't a good direction. We're going to different ways. I may have to tell the department and the college, because sometimes I get an edict, make this happen, you know, and, you know, wave the magic wand, you know, and make it happen. And that's not so easy to do, because in many of our design teams, we have 15 people, you know, I've got mechanical engineers, electrical engineers, you know, all different kinds of folks that are involved. And we have pre-construction people, and we've picked a location. And if all those things have to change, it can really set you back. And so I don't know if that answers your question exactly. But those
I think it's very good
issues that we face. So.
Sure, definitely. Dave, what about from your perspective at UC Davis?
Yeah, and I like what you're talking about, Cary. You know, if you want to get your project to go from design documents to construction documents, there's a lot of money that can be lost in between. If you keep changing the project. We had a project that had 3 PIs and 2 rooms, and it was a full remodel, and they were making changes. It lasted over a year for them to come to a decision. It cost a lot of money in architects. It cost a lot of money in DCM, our design and construction management team. But then we did get to CD, and the project is going on right now. But because of that, I absolutely put a change control process in place so that when you have so many stakeholders, that they kind of stick to what we've got planned, because a lot of things that were taken out of the project, they would want to have back in. And if we could do that, we would do that. But we had to keep to the plan and keep to the scope to be successful. We were already backed up on the project because of how long it took to get to CD. So, all that time and as project managers, we have to, be advocates for the professors to make sure they get just what they want to who's going to use the lab. But at some point, you got to have a sit down and everybody just decide.
Well, and they don't know our business.
Right.
So
exactly.
I find we have to teach them what's wrong. They think, hey, I can call the local electrician, get a plug in my house the next day. What's the big deal? And so they don't understand all the codes and the policies and all the bureaucratic stuff that we have to go through to get anything done on the campus. It has to be an approved vendor. There's just a certain amount of insurance, and they just don't get it. And I think that's the hardest thing for me also, because I'm the same way, I could call a plumber tomorrow. Why is this so hard? Why is it going to take me 3 months to get an emergency shower, for crying out loud, And so I get it. And I think it's a very difficult thing, because these people we're dealing with are intelligent, educated, and they just don't always, even if they don't, I think they understand the problem, but they don't agree with it. And there's nothing we can do about that. So that's a little bit of a frustration for everybody.
Yeah, I think a lot of it is perspective and perception, right? We all have different views of the same situation. Watch the wonderful thriller Vantage Point, not Vanishing Point, very different movie, but Vantage Point. And it basically shows like the same 15 minutes from about 6 or 8 different perspectives, which sounds colossally boring, but it's a wonderful thriller, edge of the seat. You don't know exactly what's going on till the very end. And it's a great way to really see how each person's perspective and their perceptions, their lens, really lends itself. But let's continue on what you guys were talking about. So we get into now the delivery methods, right? So figuratively delivery, right? Not actual. So sometimes it is actual delivery, right? And how that affects problems. So, and this language, CDs, as I think Dave uses, construction documents, right? For those unfamiliar with that. JOC contractors, CMAR, design build, all of these have come with pluses and minuses, pros and cons. So what's, what do you see as upsides versus downsides? And I've sort of lost track, but I'm going to try Dave first on this one.
Well, if I can get a CMAR contractor instead of our JOC contractor, I would like to do that because it controls the cost. I mean, I would, because a CMAR is just, they have the risk for the cost.
Can you help the audience understand what these are? And Cary can chime in.
Construction manager at risk. They're a contractor or contractor with they're a contractor who agrees to a set price that a job's not going to go over. So that kind of contractor, they're locked into what price that the job started with, whereas a job contractor is under contract with the college to do usually smaller projects at a certain rate. The problem with that is it's could be hourly. So to control that can be difficult if you don't watch. I like on most I like design build. I like working with a contractor through the whole process and putting together a design build. We're doing one now that's you choose your contractor. They have to do presentations to show you what they can do with the space, and you get good ideas from them. And I like working with them. There's a lot more collaboration that way.
Sure. Yeah, absolutely. Cary, what about from your perspective?
That's a whole webinar.
Yeah.
Yeah. Well, and for the audience, the old way of bidding construction was a design bid build. You were always looking for the lowest bidder, and over time it became, there was a lot of fussing about change orders and what was included and what wasn't included. And there's no set of perfect documents. And so universities and others in our industry moved to job order contracting, where you have a select group of contractors that bid to provide a certain level of expertise and work at a relatively fixed cost for the management of the project. And they get 3 bids, and then it's more collaborative. Mm-hmm. And here in Arizona, we're limited to $2 million for a job order contractor. Beyond that, up to 10 million, we have to do a construction manager at risk. A construction manager at risk is basically, they are going to bid, they're still selected, and they're supposed to negotiate and help the university as their or whoever their client is, as an advocate in the construction process. There's a lot of trust there. There's always ways people can hurt you, but on these larger projects, there's always going to be issues. And what you're looking for there is a contractor that understands your budget, your constraints, and you feel you have a good working relationship with them. And that's why it's gone that direction.
Great.
And I know I have to go quickly, John, I'm sorry.
It's all right.
Where we're in trouble now is jobs that in 2 years ago were $500,000. Some of them are coming in so close to 2 million, we have to go back, and it's a 2 or 3 month process to put out a request for quote for a CMAR and make another selection. I have a project right now that's been pushed another 3 or 4 months. We have long lead items, makeup air units that are going to take us 6 months to get. We don't necessarily want to buy those things. We want the mechanical contractor to do it because there's warranty issues. We have same thing with the researcher. He buys a piece of equipment, it arrives here. We're not going to have a lab for 3 months, but he's only got a 30-day warranty to open it up and see if it functions. So we have to go back. We have to negotiate with vendors. We have to say, hey, look, we need your collaboration and cooperation here to extend the warranty. We'll leave it crated. Or send a factory representative to install it. So all of these things you know, balloon up into other kinds of issues. And it takes a lot of coordination. Our
Yeah.
jobs have gotten much more complicated and difficult
Mm.
simply because of the material delays and the cost things that have gone up. There's only so much budget. So maybe the
Yeah.
university wants to hire 20 people, but we can only afford 10 because of the cost increases. So these are very challenging times for research.
Very cool. No, this has been great.
We just had one, and you're familiar with it, John. I'll just call it the Courtyard Project.
Oh, yeah.
It went up $1 million from when it was bid 3 years ago.
So sorry.
Yeah.
Yeah. Well, you know, we have questions, which we're going to get to in just a minute here. We're going to do a poll, and our poll is usually on just regular community webinar topics, but we really want to thank everyone. Some of you with us today, we thank you all for coming, but there's a whole bunch of you who joined our Chem Tracker product webinar 2 weeks ago. If you missed it, the recording is on our site, so please check that out. We had a great turnout, lots and lots of questions, mostly about pain points that we've all experienced in these areas. Well, here at BioRef, we're going to be delivering more of those product webinars, given how much you all said you were interested in order for us to really get a very good feel to meet your needs. So Chris is going to launch the poll. Please choose the challenges you would like to see us discuss. So Chris has launched the poll already. Go ahead. Dave and Cary, you're welcome to take a look at it, but as it says at the bottom, hosts and panelists can't vote. Yeah, it's been very interesting of late, as you guys were just saying, the challenges that we're now under, let alone the challenges that we all knew we had, just making this even more. Costs, time, a lot of which is outside of our control. And, you know, everyone, I'm sure, just gets very frustrated by it, which is very challenging to do, of course. Yeah. So let us get into the questions. And there's been wonderful conversation in the chat. That's absolutely what it's there for, folks. So glad that everyone is engaging in that. And we're going to now concentrate on the Q&A. And so the one that got the most upvotes is from Ariana, who wants to know, guys, if the tenant research group is not yet well defined, how do you design for maximum flexibility and uncertainty? And whichever of you guys wants to chime in first is fine by me.
How much money do you have?
Yeah. I was just going to say,
yeah.
Give us your best shot in a minute or two at most.
Well, I know I'm serious. How much money do you have? And we can do anything. I mean, you know, how many fume hoods do we put in? How much power do we bring to the building? How many gases do we bring to the building? Do we allow flammable and toxic gases? You know, there has to be some kind of scope. You just can't have it for everything, at least in engineering. In a manufacturing plant where you're doing certain things and you have fixed chemicals or whatever, that might be possible, or pharmaceuticals. But in engineering, when you don't exactly know what you're going to do, it's just better to have a tenant empty space and then put things in. Obviously, the more infrastructure capacity you can bring to a building, the more flexibility. You know, a larger makeup air unit, larger exhaust system, lots of power. That's a big setup. Electrical is pretty easy, but most labs are air in and air out. And so that's what you're really looking for. Big mechanical system, very robust, backup power. If you're going to do things that you can't afford to lose power, you're going to have generations or generators or multiple sources.
Yeah, and then on the air in, air out, what if you have an airlock because you have some level of clean room status in it, right?
Oh yeah, positive or negative. Like what Cary's saying, generator power, you're going to have -80s in there. You're going to have -20s. You know, you can't just plug those in. If you have, are they going to have human samples? That's a lot of money. You do not want the power to go out.
Well, and if you have computer things that are run, you want UPC. I mean, you want a battery backup. You can't afford to have everything shut down and then pop back up.
Yeah.
A lot of people need power conditioning so that they're not getting large sine wave movement in their equipment. There's so many things that we can't possibly cover all at once.
Yeah. The other thing I found helpful is they always have a list of all sorts of stuff. And I'm like, great list. Rank them. Give me the weighting of it. What's the most critical, or what's the most likely? What's the most valuable to you, that if you can't do this direction or that direction, to try to help, focus them on what's the most meaningful for them, because they'll keep coming up with ideas that might be just kind of random stuff. Cool. That was great, guys. This next one is from Nicholas. And it's what design would you recommend for the addition of molecular biology to a one-story lab? Take into consideration it's a clinical lab. So maybe the closest for engineering is on the biomedical engineering side, right? For that. But if you can, if not come exactly close to that, maybe something similar.
Yeah,
Dave?
I would say, what kind of lab? I mean, are we BSL 2, 3? What are we talking on that?
We're on the same page there.
Yeah, there's a lot of, so when you start getting into those, then you're starting to talk a lot about, like what Cary said, exhaust systems, the pressure in the room. You're talking about air exchanges. You're talking about, do I need to put in a room to glove up, to clean up?
Right, airlock.
Yeah. There's a lot of
systems for biological materials that are you can't get out of the room. That's a tough one.
Right, and there's a lot of stuff that I see come across that's good and new in the National Institute of Health stuff. You can subscribe to them. I don't know if everybody already has, but if you subscribe to them every month, they'll send you a new topic, and they go over a lot of these topics, and every month you can see what's new, and it's the latest and greatest of all their stuff. And they have a design requirements manual for just tabbing through if you have any questions.
And one of your alternatives might be use of a glove box rather than a whole room.
Yeah,
you might be able to get at some type of environmental chamber. So you're not recreating an entire lab, but you're actually putting a lab within a lab. And those are some alternatives that you might want to look at.
Yeah. And, it was interesting as I read Nicholas's, and he knows exactly what he means. And there's a lot of other people that probably do, but we all suffer from what's called the curse of knowledge. So we have all this great knowledge in our head that's very specialized to us. And we'll use little phrases that for us, we know what it means, the implications, the examples, and it's hard for us to take the perspective of someone else who doesn't have that same set of knowledge, right? And it's just a cognitive bias that we all have. So immediately the guys started asking questions. Well, what about this? And what about that? And from their perspective. So I think it's this acknowledgement that we don't all have the same knowledge base. And how do you have a conversation? Well, you just ask great questions and see what direction it goes in. Cool. Ariana wants to know, how do you assess a design firm? Cary, do you want to?
Want me to go first, Dave, or do you want to go?
Yeah, go ahead.
All right. Well, I've been on both sides of that. I did. I've got a weird background. So yeah, I've got another 10 years in architecture. What we do here, I'll just speak to what I think is possible for you. We have a long list of criteria that we need for every lab. And then we have, we run an Excel or we run a software program that pulls up when in order to do work at Arizona State University, the architecture firms have to apply with a request for quote, and they have to tell us what they're good at, tell us what kind of projects they've done. And this is all put into a database. And then we tell when we work, Dave and I probably both work with capital projects. So once we do the programming for our schools, it goes to the capital projects and the university architect, and we sit, usually we're included in a panel that selects the design firm. And we take this design firms and we try to pick the top 3 that have the closest experience and knowledge to what we want to do. And that's how we do it. And then we interview them to see, ask them specific questions because we know exactly what they're going to have to do. And we want to know what their level of knowledge is. I don't know if they did a high school lab or they did a complicated molecular biology lab at a research institute. They just put down they did a wet lab. So we have to sort of vet that and there's develop those questions, and you get better at that over time. And so it's not there's not a magic answer there, but that's how we do it here.
Yeah, Dave. Yeah, cool. Thanks, Cary.
We use a similar process as ASU does. We're doing it. I'm actually going through it right now. We're doing a coffee center, which is a food grade facility. So we want architects that are familiar with food grade facilities. So we have architects that have worked on campus that did the Mondavi Center for Wine and other core construction. They've done other stuff. So we usually start off with quite a few, and we're brought the 3 top contenders, and it's usually about 3 rounds of discussions to get to which one can give you the design that you're looking at. And we generally have the department involved too, and the end user involved in that discussion.
Yeah, I just want to add to that, Dave. We also require that they tell us how busy they are, because we have deadlines and schedules, and I don't want to get somebody that's so busy they can't take our work.
Definitely.
Yeah. Schedule is important when you can do it.
Yeah. And a coffee center at UC Davis is research and teaching. It's not the local Starbucks or pizza.
Yeah, no.
Just so people know, I've been in it. I know exactly what Dave is talking about. Same with Cary, right? And the other interesting thing I'll say is it's amazing to me, as it is always to EHS and fire codes and all, that civil engineering PIs love to bring in huge structures of concrete and then see what it takes to break them. And that has occurred. That has occurred at both of these engineering colleges. Yeah.
Tunnel sections. Yeah.
Oh yeah. No, really amazing stuff. All right. Glenda asks, I am moving into a new role as the facilities operations manager. So congratulations, Glenda, or condolences as that joke goes. I'm sure it's congratulations, of course. Any workshops or classes that can help me to learn more about this, or books or sites that you recommend? My first project is a lab reno for a new professor. Thank you. And Suzanne has put in some stuff that Harvard offers. But guys, if you have anything to suggest, I'm sure Glenda and others would appreciate it.
I lean on the NIH. I like to go to them for a lot of the stuff. They spell a lot of it out. If you have any questions, and then if you don't have a construction background, familiarizing yourself with electrical and ADA construction codes helps. It'll help to alleviate problems, in the future.
Yeah, maybe there's some in-service internal workshops or whatever that the design construction management or CPMG, they're both the same at the 2 universities, could put on so that people could understand this stuff better. It might help. Cary, did you have any suggestions for Glenda?
Sign up for a class in construction management.
Yeah.
I mean, that's a really open-ended problem. I think, I'll just use my situation. I mean, I consider myself a learner. And when I came to Arizona State University, I had only built high school laboratories. And so I read everything I could get on the internet. I went to all the seminars. I asked all the local suppliers to come in and make presentations. I went to their presentations. I spent 2 years hardcore learning about laboratories, talking to all the lab managers. I walked every lab I could find. And I tell you, it really made a difference. And so I think what you're going to have to do is, it's just that tough. You're going to have to do the work. And I bought lunch to one of our mechanical engineers here on campus once a month to teach me about the mechanical engineering for laboratories. I knew a lot about, air in, air out. I had a lot of knowledge in the units and the different types of air and mechanical, but I wasn't that knowledgeable in the specifics of acid duct work and solvent duct work and general ducts and things that had to be fire sprinklered, and things that couldn't be mixed together. Pyrophorics I'd never dealt with, silane and those kinds of things. So I would just like I think Dave said earlier, ask lots of questions, and just you'd be surprised when you buy someone lunch how much they're willing to teach you. It's cheaper than tuition.
Or at least, say, hey, I'll buy a cup of coffee at
Yeah, a cup of coffee.
Starbucks.
Yeah.
Yeah. But I was also, so Ariana said for Glenda, UCB, so it's Berkeley, Extension as a facilities management program. Well, colleges of engineering have construction management programs. And a lot of times, if you're staff at your university or college, you can take classes, maybe even just audit a class at low to no cost. So that's something, or cozy up to
or facilities
people.
management classes.
Yeah, definitely. Cool.
And lean on those, lab managers over here, department safety coordinators. They're incredibly helpful when you're putting together labs for each department.
Yeah, definitely. All right. So it's just after the hour, but if we can keep going for another 10 or 12 minutes, guys, and whoever can still hold on, we still have over 100 people on the call, which is great. Yeah. Suzanne wants to know, do you anticipate supply chain disruptions will continue to impact construction in the coming 2 to 3 years? We're in programming phase now for new R&D labs. Thank you for sharing your insights. And that was voted up by several others. So put on your predicting caps here and gaze at your crystal ball, guys. And what do you think?
I say absolutely. I don't think they've figured out the whole problem with the stuff coming into the country yet. They've started to send some of the ships up north to unload at Oakland, but a lot of materials are coming from overseas and are hitting LA and are hitting Oakland, and they're sitting out there. So, and with the trucking issues, I think there will be shortages for a while.
Cary, what about you?
I don't know. If I had a crystal ball, I'd do better in the stock market. So, I don't look ahead much, really. I'm a person who likes to deal with the reality I'm handed at that time. And I don't have to do long-term budgets. I mean, those are things that other people are going to be better at than I am.
Sure.
I know that for right now, we're 12 weeks out on stainless steel duct because no stainless steel is there for the duct guy to make the duct. So these are things that certainly in the near year, we're anticipating will be an issue.
Yeah, and we've seen problems where it's just one part, like a computer chip, that gets slowed down. Well, one part, it's the weakest link in the chain. And so with everything going on, I join the guys. I'm a little bit cautiously pessimistic about this resolving anytime soon. Sad to say, but I'm not the Oracle at Delphi either. So definitely.
Hey, it would be great if in 6 months everybody said that Dave Griffiths was wrong.
Yeah.
I'll be so happy being wrong.
Oh, absolutely. I'm right there with you, Dave. You and I can share a virtual beer together or something like that, right? Or wine, right? Or coffee. You guys make it all there at UC Davis.
That's right. Yeah,
right.
Come here, we'll make it.
Yeah. Fergal asks, I hope that's how you pronounce the name. What mechanical controls do you try to specify when it comes to liquid nitrogen and cryogenic storage and use, i.e. Oxygen sensors, exhaust airflow, etc.? How do you influence change to contribute to safety in the design? So of course, there is prevention through design as a means to do that. Marcus, whom I know, hey Marcus, thank you so much for chiming in. Put quantity of liquid cryogens per space volume may drive control specifications. But
yeah, that's right.
Yeah, what would you guys like to
take that? I've done a cryo lab, but I don't know if you have to.
No, I always work with EH&S on that and maximum allowable quantities, and that's a tough one for how much the volume is, what they're doing with the spaces.
Yeah, we do an evacuation. So we have a special, I can't remember, trying to remember who we worked with. There's a certain sensing where the oxygen leaves, and then there's a emergency evacuation. All the air goes out. Right. Not all, but I mean, it's a heavy exhaust. So what you're concerned about there is some kind of a break where there's an immediate or large release of, say, nitrogen. And you want to make sure there's breathable air and people can get out. And really, there's a lot of safety rules already in place. We're just matching or meeting whatever those requirements are. John, you may know more about that. The cryo labs that I've done, that's what we have to have, and a system for evacuating. It does have an oxygen sensor, and it drops below a certain amount, and you get an alarm, and everything goes out of the room.
Yeah. It all depends on what the space is, what its airflow is, how big the cryogen. As Marcus said, there's calculations we can do, but then it's also a design issue. You always, as you guys are saying, you always want it as automated as you possibly can, so that if there is a catastrophic release, that your mechanical system kicks in and does things, and obviously the alarms go off to warn people to get out, and pull in the emergency responders in case we have people who weren't able to get out and have passed out or succumbed to an oxygen deficient atmosphere, which is real easy to have happen. So yeah, and typically I have found that you're going to see that spelled out to a degree in at least a compressed gases and cryogens program, or at the very least, the chemical hygiene plan typically says that. But there's usually a document somewhere that's going to specify that.
Yeah.
Talk to the chemical hygiene officer and the fire marshal, and if you can get them together and buy them lunch, then maybe you can get a unified answer, right?
Well, we have
Better be a good lunch.
Yeah, well, lunch is worth a lot. We have.
I don't know why, but on school, for some reason, universities they like to.
Wait, it's the only hour per day that's not planned out. So you can actually get something done there. Where everybody's schedule is completely full, lunch you can usually have something happen. So that's a good thing.
And it's what's that saying? So Cary, I got this saying from Rick. So Rick used to work at ASU and was Cary's first boss there, and just a wonderful, wonderful guy. I learned so much, not just work, but life from Rick. Wonderful guy, retired now. He said to me at one point, I totally agree, John, I get more done in the halls and on the malls than in my office.
Yeah. That's been the problem with COVID.
Yeah, exactly. I was just going to say, COVID has done that, but, hopefully these days we're able to get out more, engage more in a little bit more of a natural sort of way, especially outside, which our campuses allow this time of year. All right, let's try to get in one, maybe two more. Alessandra wants to know, I would like to talk about new buildings. It seems to me that architects and engineers build brand new buildings, not having research in mind. Are there EHS personnel and researchers that participate in designing these buildings? It seems, I think that's a good question, well asked. It seems to me that they are just worried about looks, and it is clear that they are not appropriate for research, and there's an exclamation mark. And then of course, a couple of nice colleagues, Nancy and Grant, have chimed in, but what would you guys have to say about this? I know both of you have had new buildings on your campuses.
Go ahead, Dave.
I'm sorry, John. I didn't.
Oh, sorry.
Question. I'm sorry.
That was sneaky, Dave, but okay.
Yeah. What was it? What do we do with it?
Well, what about new buildings, and are architects and engineers really trying to design for the research, or really trying to design for how it looks? I think is a good summary.
Yes. Yes. So our campus standards. I used to work for facilities for the campus. So when I worked for facilities for the campus, I was on the plan review committee for what would, to make sure that everything was up to campus standards. And architects absolutely don't seem to care about campus standards. They really want to go. I mean, that's a blank statement. They want to look, and I respect that. And they really go for certain things to look certain ways, and they really want to present it a certain way. But our job is making sure that the thing we're tasked with, they always tell us that in facilities that whatever we build should last for minimum 50 years. So everything that goes in that building, the campus standard says is going to last 50 years. So when they come up with certain design options that look a little better, doors, doors, you want to go with a super low pro entry door. No, it has to have a certain thickness of metal at the bottom, has to have a certain thickness of metal at the top, and it's just a longevity thing. But the architects don't often feel that it looks as good as what they design, and I get that and I appreciate it. But we have to have spaces that last a long time and that don't require huge amounts of maintenance.
Yeah. Great. Cary, did you want to chime in briefly?
I'm with Nancy. The last two buildings they built on campus, they didn't even ask me. And I know that the architects go in and they design something that's going to be, they're not going to, be specific to what our department needs, our college's needs. We have a really great team here of people that have a lot of experience, and I don't understand that either.
Yeah.
They did one here on campus, and they skirted some of it. There's some of the review, and some of the review was actually, and this was overridden by design and construction management. They changed some things. Well, after that building was built, I went and did a $50,000 project on that brand new building,
right,
to bring it up to campus standard.
Right.
So,
we have it. I don't want to commit political suicide here, but I mean,
yeah,
we built a whole brand new building, and there wasn't one gas cabinet in the whole thing. And all of a sudden, somebody wanted to use a flammable, and it was ridiculous how hard it was to go in there and put in a gas cabinet. I don't know why they didn't think of that. They knew what kind of research was going in there. Fancy firm out of the back east or whatever, and local firms to do the dirty work of all the drawings and CDs. I can't explain that. So
yeah, sad. We're not gonna be able to answer every question. We got one more left.
We do a great job here, though.
No worries. The next one, and maybe we can just do real brief answers, guys, and then we'll wrap it up here because it is getting towards quarter after the hour. But we love everyone that's been able to stick with us. And guys, thank you so much for everything. But Ariana did ask a good one, and all the questions are great, folks. And I'm so sorry we can't get to them all. How do you deal with lack of responsiveness or engagement or proactiveness? Now, Ariana asked, with facilities. And I know both of you guys can speak about that. I'll add in, because the three of us talked about this in our prep meeting, or from the PI themselves. So this is more, I think, on the soft skill side, which might be a great way to end today. So Cary, do you want to go first? And
well, as I started out earlier, I work very closely with facilities, and I try to help them as much as I can. I've spent a lot of time building relationships with all of the upper management and all the way down to the electrician. I know their name, I know how many kids they have. I say hello to everybody on campus, because at the end of the day, we're all a team, we all work together. I don't believe in a hierarchy for that reason. Everybody here is supporting their family and wants to have a nice place to work. So in construction management and many other types of management, they call something similar to what John talked about, who's on your molecule. And you're talking about that as you're walking through campus. I always make time for people, and they respond to that. And it isn't done manipulatively, it's just the way it is.
Yeah.
And it's not unusual for an electrician or a plumber here to have 50 jobs backed up. And so at some point you have to develop a respectful relationship with the authority, having jurisdiction, or the person who's doing the scheduling. And what we have here is it's sort of a handshake agreement that once in a while we can prioritize something and they'll stop what that guy's doing and put him ahead of the line.
Yeah.
You can't do that all the time. So it has to really be important.
Yeah.
And so that's how we do it here. It's not easy, and nobody wants to play favorites. But people respond a lot more to niceness. What is it? Honey gets more than whatever,
vinegar,
salt. And that's
vinegar.
The truth. People who complain all the time and they're unhappy and you can't make them happy, they just don't even bother. So it's really important to develop those relationships.
Sure.
When someone does something, here we can, I know, I'm sorry to go so long time. We can send a little reward or certificate to their supervisor thanking them. They love that stuff. They don't, lots of people complain, very few people praise.
Yep.
And so
Well,
I would suggest more praising, less complaining. And over time,
Great.
I think you'll see a change in the attitude toward your new.
yeah. No, it's well said, Cary. Dave, what about
Yeah,
from you?
well, you know my relationship with facilities. I mean, I agree with Cary 100%. When these guys are in your buildings and they're doing things, get to know them. They're all teammates. We're all working for the same place, and really getting to know them works. I have their phone numbers. I can usually give a call and get advice, or get someone to just stop by because I have a relationship with them. I know them, and they'll do that for me. And it just happens over time. And those guys are great. They're there to help. They do the best they can. So I treat them like that. And
right. There's policy, and then there's sort of the underground network.
So true.
I also golf with them every 2 weeks.
Yeah.
Oh, that's just because they like winning.
Yeah, I think that's true.
I won't talk about golfing right now, Dave. So thank you all so much. I will add to this, to what Cary and Dave said. Everything they said is just fantastic. Appreciation should never go unsaid. Absolutely. And the other, and there's a good article on this, look up near NIR and FAR on Carl Rogers' approach. His was to therapy. He was a psychologist and an educator. And what he created was unconditional positive regard. How do we have unconditional positive regard to people in our everyday lives? Because we just don't know what's going on in their life and the stressors that they're under. It's a great way, and it's a good article, near NIR, it's a guy's name, and FAR, on unconditional positive regard. Check it out, folks. If you don't find it, shoot me an email. On behalf of everyone here at BioRaft, to both Dave and to Cary, thank you guys so very much for coming. And to all of you who came and stuck with us all the way, thank you for coming. We look forward to more. I will see you all in 2 weeks' time. Take care and be well.
Thanks, everybody.
Bye-bye. See you guys.